let's create a private Kubernetes cluster, private Kubernetes EKS cluster. Let's write Terraform file for that. Let's start with VPC. Name, what name? EKS VPC will give. Cider block. Class 16. Let's add tag also. Let's add internet gateway for it. It's a private cluster, so we will be creating a completely private cluster. So we don't need public. We would require public subnet because we will be creating a Bastion host in that public subnet. We'll be creating that. Let's see. Let's create internet gateway for public subnet. Let's give EKS IGW. VPC ID would be AWS VPC dot ID, and let's give tag also for this also. Let's create public subnet. Public subnet. Public subnet will be using for Bastion host. Resource AWS subnet. Let's give EKS public subnet. VPC ID. Cider block. Let's give 10 1 0 5 0 /24. Availability zone. Try to create element. We are fetching data. I'll be writing data also, fetching data also. I'll fetch 1, fetch the 0, so AP South 1 A. It will fetch AP South 1A. Map public IP on launch. True. Tags. Name. EKS. Public. Subnet. Let's fetch the availability zones also with data. I will be fetching the availability zone and will be selecting 1A. This 0 means 1A. So yeah, this is how we will be selecting. Let's create a private subnet also. Same thing would come. I've created this subnet code. This is the code actually. So we'll have 3 subnets in each zone, 1 subnet. So and CIDR range it will take 0 0 0 1. It will take 10 1 1 0 24 2 2 0 24 3 0 24. It will take like that, and it will fetch the availability zones from this, and it will try to add in count we have given, right? It will try to add in count. It will try to create. And subnet name also we have given: EKS private subnet 2, EKS private subnet 3, EKS private subnet 1. Now let's create a route table, private route table. The reason we don't have this configuration in the public subnet is we will only need one public subnet, because we are only using for hosting Bastion host. Will not be using that. Resource AWS route table, private route table. This is the name which you want to give. Internal resource name. What's the VPC? VPC ID. AWS VPC. What ID? Route CIDR block. Will give across the internet. You should go through NAT gateway. So we'll be creating NAT gateway also, but yeah, let's add NAT gateway also. AWS NAT. NAT gateway. Let's add it later. Let's keep it like this. Let's add it later when we create NAT gateway. As our cluster is completely private, so we would require NAT gateways, right? So we'll add it later. Yeah. Let's keep it like that for now. Name private yeah, that's all. Now we have to associate this route table. Yeah, let's associate route table. AWS route table association. Let's give name private table association count 3, right? 3 subnets we are creating. So count 3 subnet ID. Subnet ID AWS subnet EKS private subnet count index we have to give. Count index. It will count from the index. It will count from here and it will try to add it. Route table ID AWS route table that's all. Route table is created. That's all. Now let's create for public subnet also. Let's create a route table. Resource AWS route table. Let's name it as what will we name? Public route table. Resource name which will give public route table. VPC ID AWS VPC dot ID. Route cider block. Let's across the internet will open because it is we are using it for Bastion, right? So will across the internet will open and through gateway, internet gateway. Let's give tags also. Now let's associate this route table. Route table ID AWS route table public route table. subnet association as it is a single subnet. AWS subnet. That's all. Let's create NAT gateway also. Resource AWS EIP. It should be written after creating NAT gateway, but anyway we are writing it. Domain VPC. Resource AWS NAT gateway. Let's give name as EKS NAT gateway. Allocation ID would be AWS subnet ID AWS public subnet dot ID. It should depend on creation of internet gateway. Yeah, it depends on creation of internet gateway. After the internet gateway is created, it will get created. So that also is completed. Let's move on to roles. IAM roles. There's set of defined IAM roles we have to create for EKS cluster. That will become right. So now we'll be creating IAM role for the Kubernetes cluster, EKS cluster. Let's create IAM role. Resource AWS IAM role EKS master role. Name, we would like to give name EKS master role. It should not be hyphen, it should be this. It's assume policy, so that I'll tell you why assume. Why do we assume policy? We require a sample. This sample we would require this. Assume role policy. let's create role, associate role, AWS IAM role policy attachment. We would require this role. Well, this policy actually. So let's search for the policy. Yeah, this policy we would require for EKS cluster, for creation of EKS cluster. Policy ARN. Policy ARN would be this, and later role. What is the role? AWS IAM role EKS master role name. We have attached this role to, and one more policy we would attach, and the policy is this policy we have to attach. Again, we would create another resource. These roles, these policies we have created, and this role will be created, and we are telling that to use, sorry, EKS. We have to tell EKS. We are telling EKS to use this role. We are telling EKS to use this role. So EKS use this role. So indirectly we are telling EKS to use this role. Use these two roles. We are telling assume this role. That's all. create a Terraform file for EKS cluster, for creating EKS cluster. Source AWS EKS cluster. Cluster name would be EKS cluster. I would name it as EKS cluster. Internal name. Naming I will name it as private cluster. Name I would like to give private EKS cluster. This is the cluster name, and role ARN would be AWS IAM master role dot ARN. Yeah, and version would be we'll use 30. It specifies some other details also. VPC config, subnet IDs, AWS subnet EKS private subnet. We'll use star. We'll take one by one. Dot ID. Endpoint, let's endpoint private access true. Endpoint public access false, because it is completely private cluster. Security groups, we'll write security groups. AWS security group. Let's name it for now. EKSSG dot ID. Let's name it for now. We'll create it. We'll create the security groups later. Kubernetes network configuration. Service type. So 172.20. We'll put this into variable later. Enable log types. What are the logs I need to be captured? API logs, audit logs, authenticator, logs, controller manager logs. We need control manager logs also. And then we would require scheduler logs also. Once this is done, we will create depends on AWS policy attachment, right? AWS IAM role policy attachment. Cluster policy this, resource controller this. Yeah, let's put this into variable. Let's create a variable file. Cluster service IPv4 spider. Description would be spider block for Kubernetes services. Default 172.16 172.20.0.0/16. Now let's change it. We have changed it here. That's all. This configuration should create EKS cluster, and we have to create for node group also we have to create a file now. We'll create a node group file. Yeah, cluster configuration is correct. It is completed. Correct. It is correct. Let's create cluster once node group is created. Let's create now file for node group EKS node group.tf. Let's create. Resource AWS EKS node group. What name we should give for the node group? EKS node group. This is the name we want to give. And that's okay. Now cluster name should be AWS EKS cluster dot name. So that would be used reference through name. And node group name EKS node group. Node role ARN AWS dot ARN. And next subnet IDs. Let's give AWS subnet EKS private subnet. We'll give star again dot ID. Remote access, let's give it as EC2 SH key. It would be testing is a key I have, testing dev1. This is the key. I want to SH into the node. Scaling config, let's see, desired equal to 1, max size for now I am giving only 1, min size also 1. For now I have given only one because I don't want many nodes to be created, given only one. Instance type T2 medium. Let's give tags. Update config. Update config. Max unavailable, I want only one. I can give percentage also, but I'll give number. I can give percentage as 50 or something. These brackets are not there, sorry. Depends on errand policies, right? AWS IAM role role policy worker node policy. Worker node policy, we don't have worker node policy. Let's rename it as yeah. AWS IAM CNI policy. Container registry. Let's rename it. policies. It depends on 3 policies. Once these policies are created, then only the node pool will be created. That's all. That's all. Now we will create security group. We have added one security group, right? This one security group in cluster, in EKS cluster. So this security group will create. Yeah. Create Bastion. Resource AWS instance. Bastion is straightforward. AMI. Let's put it in this variable actually. I have an AMI which is we can use it. Let's put it in variable AMI type description, the image to be used. Type string, default value would be this. Let's create variable for instance type also. Variable instance type description instance to be used. Type string, default T2 medium. Yeah, that's enough. We can now create Bastion. Instance type var dot instance type var dot AMI type subnet AWS subnet public subnet key name testing dev 1. I have the key, it is already downloaded. I have, so I'll keep it in this folder. I'll keep it. Yeah. User data will write to create user data to install 𝐶ubectl and EKSCTL to configure to connect to the cluster. So I'll write user data also, but before that I'll write security groups. Group IDs, AWS security group, let's name it as Bastion SG dot ID. Let's give tags also. Associate public IP address true. depends on, now I want Bastion to be created after cluster is created, because in user script will be writing a command to connect to the cluster, but once cluster, what happens is Bastion will be created at the same time when EKS cluster is created. So Bastion will not be able to connect to the EKS cluster, and the script would pass, and then nothing would happen. So because of that, I want to create Bastion after EKS cluster is created. AWS EKS. That's the reason. Let's create security group also. Resource AWS security group. Let's we were supposed to add one group, right? Add one security group to EKSSG. EKSSG, right? We are supposed to add this. So I've created it. VPC ID, AWS VPC ID dot ID created. Now let's write ingress. Ingress, what do we want to allow? We don't want to allow anything. We just want traffic to come through. Only Bastion should be able to access from port 443 to port 443. Protocol TCP security group. We will create Bastion SG also below, so we'll write it. Let's write it. Security group dot ID. We'll create security dot SG. Bastion also. Let's create Bastion also. Egress, what do we want to go out? Let's outbound. Let's keep everything. Anyway, it is private, so it would go through NAT gateway only. Protocol -1, let's give -1. Cider block, let's give across the internet, we'll give for now. Let's name also. Name what we'd like to give, EKS Cluster SG. Let's create a Bastion SG also now. VPC ID, AWS id ingress. Let's allow port 22 from the internet. Header block from the internet, from across the internet will create. egress let's keep same. Tags, let's add tags. Bastion SG. So now we are only allowing Bastion host in EKS SG, in EKS security group. We are only allowing Bastion host traffic to come into EKS cluster by attaching Bastion host, Bastion SG, attaching this. We are allowing this. Let's see if we have added the same security group. Sorry, no, not same. This thing. EKS SG. Yes. Yeah, we have allowed this. We have used the same security groups now. Yeah. So what we are referencing Bastion host traffic to come into EKS cluster through port 443. That's all. Now we can proceed to create user script for Bastion host, so that EKS CTL, 𝐬𝐵CTL should all be installed by automatically. Let's do that. Now let's do that, but before that let's create output also, output file also. Bastion public IP we need. We would also need EKS cluster endpoint. This cluster endpoint. Value AWS EKS cluster dot EKS is cluster endpoint. We want cluster name also. Value AWS EKS cluster, AWS EKS cluster, EKS cluster name. Yeah. We Bastion host public IP. Bastion host public IP. Done. Now everything is created. Just we need let's copy SSH key. I have testing dev 1.pem. I copied that also. Now let's create Bastion host user script. We have to install authenticator and all, so we will be installing directly through user script. When the Bastion host is created, I want all these things to be included in the server. So configuration is completed. Now Bastion host user script, if it is done, once it is done, then we will proceed to create the complete code now before we execute the cluster. First we have created VPC. We have given CIDR range as 10, 1, 0, 0, 16, and then we have created internet gateway. Internet gateway we have given name EKS 𝐏𝐥𝐞𝐚. After that we created public subnet, and we are fetching the data, fetching the availability zone in the particular region, and on the base of that we are passing the availability zone data. We are passing it into this thing, and we are taking 0. That means it will take AP South 1A, and this is the configuration for public subnet. And for the private subnet, we have given 3 as count. So this is the private subnet name, and we are using count 3, right? So it will create 3 subnets in 3 different zones, and each subnet will have its name. EKS private subnet 1 in AP South 1A. In 1B it will be 2. 1 3 it will be 3, and it will be /24. Like we are giving 8, right? So it will take /24. After that we have created route table for private subnet. Private subnet, the network should go out through internet gateway. We have created internet gateway, and after that we have associated route table and public route table also we have written code. It is going through internet gateway outside, and if we check here, this is also associated to public subnet. Route table is associated here. Then we create a NAT gateway. NAT gateway we gave name as EKS NAT gateway, and this is created in public subnet, and it depends on EKS IGW internet gateway. And after that we created IAM role, EKS master role, and this is the policy to assume this role. Like EKS will have permission to execute these roles. We are giving EKS to permission to execute this role, to assume this role. These are the 2 roles which are required by the cluster, and we have created it. These roles will be created in the cluster, in the account, and that will be attached to cluster. During cluster it will be attached, and these are internet node group, and these are node groups. And here also the same, it will assume EC2 instance will assume these roles. It will assume. There are 3 roles which are required now. Amazon EC2 content read only, Amazon EKS CNI policy, Amazon EKS worker node policy. three policies which we require, and these are the three policies, and this will allow EC2 to assume these roles actually. So that's why we have written this. And EKS cluster we are naming private EKS cluster, and we have given EKS master role ARN, and then version 30, and then public subnet we are subnets we are giving private subnets, and then private access true, public access false, and security groups EKS-SG security group I have created, that I have added here. And Kubernetes network config we are giving 170 to 20 range. We are giving 170 to 20 range for network started for Kubernetes services. And then these are the logs which we require. We need logs of API server, audit logs, and authenticator logs in control manager, and scheduler logs we need. So it will log in CloudWatch, and this complete EKS cluster will depend on the cluster policies. The role, these are the roles which are it will depend on. It will create after these roles are created. And in node group also the same. Cluster name we have to give, and then node group name, and then node role we have to attach. We have attached node role. It will be created in private subnet, and remote access we have to allow. This is the key. These are the desired configuration. Desired is 1, max is 1, minimum is 1, and instance type is T2 medium. And this will also create after these policies are created. And these are the variables. This is the Bastion host. Variables I have added, AMI type, instance type I have added in the variable section. And this IAM role which I have created just now, I'll show you. This is the IAM role which I am trying to attach. Rather than giving access key secret key in the Bastion, I would prefer giving IAM role and giving limited access to the Bastion, like limited access related to EKS. I would want to give it to Bastion. So I have given that limited access. And then bastion.sh, this file I have written. I'll discuss it in the next video. But this file I have written already. And security group Bastion SG, map public associate public address is true, and it will create after EKS cluster is created. This is a security group. We want to allow only Bastion to EKS, so I have allowed only Bastion to EKS. And to Bastion it is port 22 anywhere from the internet. This is the role. Let me check the role. I have limited access. As IAM is global, so it will not be specific to particular region. So it will be, let me check. Role name, what is the role name? EKS Bastion role I have given. See, I have given only EKS related. Get, delete, describe, update, create, EKS related permission to Bastion. So it will only have these permissions. I gave all the permissions, EKS related permissions I gave. So it will have that. And this is the Bastion file which I have written. It will download the particular platform. Like if it is architecture, it will AMD 64. It is AMD 64. It will download AMD. As I am using Ubuntu, We'll download AMD64. This is the file which I have written. I'll discuss. So these variables I am passing as a variable. This uname -s, it will give the kernel. It will give kernel name. It will give kernel name, architecture name, kernel architecture name, and this I am fetching it from GitHub. I have followed AWS documentation. This will try to install EKSCTL and update, and after that it will try to. I followed Kubernetes documentation to install 𝐶ubectl. It will install the necessary packages here, and after that it will try to get this keyring for 𝐶ubectl for package, Kubernetes package 29. It is 29. I'm downloading 29. It will assign the keyring package into kubernetes.list, and then it will install 𝐶ubectl. After that it will install AWS CLI, which we require to connect to the cluster, because we'll be connecting to the cluster using a command, right? So this will be required. So AWS CLI, after installing AWS CLI, since I'm running this command, I'm running because it will prompt for the interactive screen. It will come, interactive screen will come wherein I have to press yes, Y. So to avoid that, I've run this command like install -dr. It will skip that interactive screen. It will allow me to run that command, and after that it will connect to the cluster. After connecting to the cluster, what happens is kubeconfig. In that kubeconfig, I have to replace one alpha to beta. There is a place in kubeconfig wherein I have to replace API version client. I have to replace this thing with this thing with this thing. I have to replace in the kubeconfig file. So for that I have written a script. This is the path where kubeconfig will be copied. After that I'm taking a backup of that kubeconfig. After that I'm copying the config file with backup. I'm copying the config file to backup file. After that it is updating the alpha to beta using sed command, sed-i, and after that if it is successful, it will get updated, and if it is not successful, it will restore back to the file, to the same file wherein alpha was there. It will try to replace to the same file wherein alpha was there. I'll show you what alpha, what beta I'm talking about tomorrow when I create the cluster. Once it is updated, it will update a file, and it will create a file called as updated.txt. By this I'll understand that the script has run successfully till here. That's all about bastion.sh file, and bastion.sh file we are attaching it to Bastion host user data. That's all. That's a complete understanding of the code which I have written for EKS cluster, which is created in private and accessing it through Bastion. Yeah, that's the Terraform code which we have, and so we'll try to create the cluster now. We'll try to create the cluster node pool with one node and Bastion host for connecting to the cluster. So let's create that. So this is a script which we are attaching it to Bastion to connect to the cluster. So this is the complete script. So we'll be creating the cluster now. Let's create it. It will take almost 20 minutes, I guess, for complete cluster to be created. Let's see if it's created. It is creating. Let's wait for it to get created. After that, we'll try to connect to the Bastion host and then try to see if it is getting connected to the cluster. It is still creating. Let's wait for it to get created. It has created EKS cluster and also the Bastion. Let's connect to the Bastion and see if we are able to connect to the cluster. Let's check if it is script ran. So let's check if it is getting to connect to the cluster. We have one node in node pool, right? So let's get. We are able to connect to the node pool also. So we are able to connect to the cluster. So we are able to connect it. So that script worked. So that's all. This is what I wanted to show. So once the cluster is created, so we are passing user data, and through user data we are configuring to connect to the cluster using user data. So this is the overall cluster creation video on EKS cluster, private EKS cluster. If you like the video, you can please subscribe the channel, or you can share it with your friends, or you can like the video if it is possible. Yeah, thank you. Experiment is complete. I would suggest you to delete the cluster. Let's delete the cluster. It would take some time. It would take around 20 minutes to delete the complete resources. So wait for 20 minutes and try to delete the resources after experimentation. So let's not wait for it to complete, but I'm pausing, I'm deleting, I'm stopping the video. So it will go on and it will delete the cluster. So that's all I wanted to cover. So yeah, that's all I wanted to cover in this video. Thank you.